frightened if we have to. Oh yeah. But, so with 6-3, oh my gosh. When you're doing these, I don't care whether you do them vertically or horizontally. Find what works for you and kind of work with it. When we're saying add the polynomials, basically no matter which way you're doing it, we're basically just saying combine like terms. So if they're lined up vertically, it's kind of nice. Just add down. Notice I'm not changing any exponents. Okay, we only change the exponents when we're multiplying or dividing, not when we're adding or subtracting. And I'm done. You're like, cool. This is totally different. Okay, if it's horizontally, just look, again, for the largest exponent first, because we want to write them in standard form, which starts with the largest degree. Maybe I'll check it off as I use them here. And work your way from the largest degree down to the smallest, where we get to our constant term. And these seem easy, but people tend to blow through them so fast that they make careless errors. So be careful still with these, but have confidence, because life is going to be easier. Now here's my suggestion when you're subtracting. Yes, it's easy to just kind of look and go, well, I'm just doing minus, how hard can this be? I would suggest, yeah, here's what I would do. I would distribute that negative through down below here. So basically I'm changing all the signs, and then I'd just quick rewrite the ones above it. Because now it's just like the add one was right above in number 1. And I'm not going to have to worry about, did I do the minus or not? Did I forget it? I don't remember. And now I can just add down. And again, if you're comfortable just looking at the minus, you can, but I'd probably do that. And I'd probably do the same thing if I was doing it horizontally. I'd probably distribute through. I'd rewrite my first set of parentheses, and then I would distribute the negative through. Before I went back and combined like terms. Okay. So basically, yeah, it's just fancy combining like terms, except we're just writing them in different orders. Now, oh boy. Multiply the polynomial. Okay. When we get here, I'm not going to teach multiple ways. I'm going to teach this one because of what I've seen over time. I would prefer that you not try to do this like you would a FOIL problem, because I've seen way too many people forget terms, do terms twice. So here's the hearty suggestion. I know you're going to groan when you see this, but I'm telling you, it's going to organize you. In this case, I've got a trinomial and a binomial, so I'm going to make a 2x3 box. And I'm going to put each of my terms going along the edges of the box, and then you multiply to fill it. So basically, I'm doing like what you would do in a FOIL and multiply, except all my terms are going to end up in this box. So again, when you multiply, you're going to add exponents when they both have a variable term. So negative x to the third plus 2x squared plus 4x. And again, little things. Negative times negative is positive. 3x squared. 6x minus 12. The nice thing also about doing it this way, it puts the whole problem in standard form order for you. If you start in the upper left corner, anytime you do a box, that's going to be your first term. And then each diagonal below it are going to be your like terms. But again, watch, once the box is filled, okay, this is where you have to be careful because I'm not adding exponents anymore. Then I can put together my x's and finally my constant term. And again, just me. Some of you may feel comfortable doing like a distribute all the way through on these and doing it that way. That's fine. I just really, really, really like doing this box way just because of the way it organizes everything. And again, this is going to be more attention to detail than anything else. Just making sure I multiply, I add my exponents together. Another nice thing about this way is, because you know where the like terms should be, if you get an exponent that's off, you're going to take a minute to look at it and go, wait a minute, I know that shouldn't be there that way. So let me kind of see how this goes. So multiply the coefficients and add your exponents. And again, just start in the upper left corner. Start working your way down. Being very careful that you're adding now, so we're not messing with the exponents anymore. And get it multiplied out. One twist to throw in, though. Just one. Number 7 is kind of tricky because I have not figured out a way to do a 3D box yet. Okay? So since we cannot do a 3-dimensional box, and have 3 different sides going at once, we're going to do it in pieces. When I see more than 2 sets of parentheses, I'm only going to deal with 2 at a time here. So again, I'd foil this out, or I'd do a mini 2x2 box on this to work this out. So once you've done that, I'll just show you what it should be here at the end. Those first 2 binomials, x minus 1 and x plus 4, should multiply out to x squared plus 3x minus 4. The first 2. Yep, you could foil those out, or you could do a 2x2 box and get the same thing. If I multiply this out, I get x squared plus 4x minus 1x minus 4. Then I just combine my 2 x terms in the middle. But remember, I'm not done yet. I've still got this x plus 3 sitting here. But now it looks like what we've done in the first 2 problems. I have a binomial, I have a trinomial. So again, whichever method you're comfortable with. If you like the distributing, distribute. Otherwise, organization's an issue. Again, I'd set up one of these 2x3 boxes. And I just multiply through. And again, just adding my exponents, multiplying my coefficients together. And just like it has been on the others, my like terms are together. At this point, I'm leaving the exponents alone. And I'm good to go. And then 8, I'm not even sure why I put 8 on here, because that's just normal foiling. Which, shoot, we foiled and foiled and foiled this here. Just to be sure. We'll get that in there, just in case you want something to be able to take a peek at and double check your foiling skills. Then comes things with these wonderful shortcuts, if you understand them, and if not, you can always go to the old faithful thing to back up on. So if we flip over, now we hit the special cases. Sums and differences, and what's called the square of a binomial. Now, could I still just write this out as x plus 2, and FOIL it out and get an answer, or use a 2 by 2 box? Yes, I could. But I sort of want to use these as an opportunity to introduce these little shortcuts called the square of a binomial. And here's how it works. Your first term would be what we call A. Second term is what we call B. So if I plug into this pattern for A plus B squared, I square my first term, x squared, and then I add 2 times the product of the two numbers, so x and 2, plus the square of my last term, x squared. Well, and I was just going to say, some of you are going to find that you think you'd rather just FOIL this. And I totally understand if you want to do that. Sometimes these so-called shortcuts or special patterns, I don't know if they're really short or not. Because this is just me. When I look at this one, some of you, again, are going to say, well, I'd just FOIL that out. And that's fine. But I'll just show it one more time just in case. So again, my A term, I have a minus in the middle, so I'd follow this one right above it. So I'd have 3x quantity squared minus 2 times the product. Now, some of you, when I do this, are going to be like, wait a minute. You're like, why are you using 4 instead of negative 4? Because when you're doing this, the minus is part of the formula. Whatever's over here is just the number itself. So I couldn't use negative 4 in there. It's going to mess my signs up. And like I said, some of you are going to say, you know what, Hardy, I'm just doing the box or doing 4. And that's fine. I just want to make sure you don't think I can just square this and I'm done. That'll drive me crazy. Because all I'm basically doing is this squared, and 2 times the product of those two things.
So can you do a box that with me?
Oh, absolutely. You absolutely can. Any one of these that you do can absolutely just continue to be FOILed out if you wanted to do that. These are just little things for you to think about. So like if you have a plus and minus with that, the middle 2 terms are going to go away. Again, just something to consider. For which one? Okay, but here, I'm actually trying to multiply this out. It's not like I'm trying to solve something. He's right. If I was trying to solve it, you're right, I'd want to look for a square root or something. And if there was an equal 0 on the other side, I absolutely would. But here, since we're just multiplying it out, yeah, I don't want to break it down at all. I just want to multiply that out. And then again, when it comes to the cube of a binomial, okay, it's a good form to know, but when we on the front did that part before where we said, okay, basically I have 3 of these, and I would just do the first 2 and then work that out. This one I want to show you both ways. Then you can kind of make up for yourself how, determine for yourself how you want to do this. If I did it this way, I'd get x squared plus 6x plus 9 for my first pair if I multiplied it out. Then I'd have this guy left. So in that case, I'd say, okay, I'm going to do the box on this. I'm just going to work this out. And whatever I get from this final box is what my actual answer is going to be. And just like it is every time, if I use the box, my like terms will take care of themselves. Okay. I was going to say, for those of you that are creatures of habit and you like to just be able to do the same thing consistently, this is perfect for you. Okay. The only other option with this, okay, is if you're using the actual form. And again, I'll show it. And again, but how you want to do it, your deal. Nope. If you want to do it this way every time you see one of these, you've got that option. Here, again, I'd have my A and my B. If I knew the form, and you notice like it goes from 3 to 2 to 1 to 0 with my A's, but the B's go up 1, 2, 3. So what I'd do is I'd have, okay, my first term cubed. Again, some of you are going to like, I'll watch this, but I don't think I'm going to do it. And I'm just following this. So plus 3 A B squared plus, I'm going to run out of room, 3 cubed. And then I just multiply out. 3 times 3 is 9x squared. 3 squared is 9 times 3 is 27x. And 3 cubed is not 54. Hardy, come on. So I get the same thing either way. Yeah, 4 cubed is 64. So either way, it works. I'm going to assume for a lot of you, the way on the right is probably the route you're going to run. And that's fine. I'm not going to scream and yell if you don't want to deal with the two-bit binomial. There may get to be a point where we want to head that direction, but for now, that's fine. Last thing. And again, don't let the story problem drive you crazy. This one especially. Like, okay, from 1985 to 95, the gross farm income and farm expenses in the United States can be modeled by, here's my income, here's my expenses, where T is the number of years since 1985. Write a model for the net farm income for these years. Okay, if I know how much income I took in, and I know my expenses, and I want to figure out how much I took in net after expenses, what would I do? Subtract them. So basically, we're going to do income minus expenses. In other words, this minus this. And now it's just about doing it with like terms. Negative plus the 159, because that's my income. And I'm going to subtract my expenses. But again, when I subtract it, that minus goes all the way through to all three terms. Tell me I'm taking too much time. I don't care. I'm going to go ahead and write out those last ones just so I don't do something silly. So that 0.174t squared becomes negative. My t term does, and my 1/3 does. Now I just go through looking to see what I get for each of these. Why I didn't finish this, I don't know. $188 minus 254 is 534 t, and that would be 28. And that's it. Because they don't tell us to find it for a specific year or anything else like that. This basically said, write a model. Okay, that's my model. N equals all that business. Your job? Oh, I was gonna say, wait a minute, I know these aren't all story problems. Let me double check. I would like to say story problem wise, I've got a number in my head, but I don't want to say it so I look. 1. 64 is the only one. And it's eerily similar to the other one. So don't skip it.